Hi, I'm Roberto Lamberts. Thank you for attending this webinar. Jan Hensen and myself will give you an introduction to the book Building Performance Simulation for Design and Operation. Let's start with the context. Why do we need building performance simulation? World population is still growing and becoming more urban. By 2050, 80% of the world population will reside in cities. We need a lot of new buildings because of that. Urban density is increasing, and with it, urban heat island and complexity to understand the effect of one building over the others. Energy consumption is increasing substantially to attend this population growth and world development needs. Also, energy sources are changing, and the complexity to operate the electric grid with a lot of renewables and smart grids is a challenge. Climate is changing, and we need to design buildings that will last 50 to 100 years. Buildings that will operate in future climates that we don't know how they will be. Buildings that will have to be energy efficient in climates they will face in the future. Also, in the developed world, we have a slow change. Existing buildings will last for a long time, and we have a very small renovation. In Europe, for example, only 1% of new buildings are happening every year. So we have to retrofit the existing buildings and have to be able to understand their behavior. Buildings are becoming very complex. We are designing buildings with a high degree of complexity, and we need to understand their behavior. Normal building codes and rules of thumb will not work with this kind of buildings. So simulation is a must. Another example of complexity to be designed and to work properly to attend the human comfort aspirations. Building integrated photovoltaics. We are generating energy on the building itself and need to understand its dynamic behavior. Sustainable built environment will start to change slowly from general energy generation to more complex grids involving photovoltaics, involving probably new kind of generations, renewable generation. We will have energy storage, we'll have wind, and with this we'll probably help to reduce our problems with the environment and reduce CO2. And for this we need to understand and simulate properly integration of distributed energy, demand generation, storage, and distribution. We have higher comfort demands. Building users are have higher comfort demands. We have to be able to analyze adaptive thermal comfort, the provision of thermal and visual delight, daylighting and glare problems, acoustic performance. We want healthiness. Building users demand healthy buildings. Building performance plays a very important role in the scenario. Now I hand over to Jan to continue the presentation.
Thank you, Roberto. So I think you should now see my screen. And so the overall goal, I think we as a field are working towards is a sustainable, energy positive built environment. But it's not only about energy. We also have to optimize indoor environmental quality for comfort and or productivity. And in order to do so, the built environment has to be looked at as a multi-scale, multi-physics and transdisciplinary area. We need to think of technological solutions for energy generation, storage, distribution and demand reduction, and to integrate and optimize that in design, construction and operation of new and existing buildings. This is a tremendous task, I think, which will require lots of brain power from many people. But we also think that computational building performance simulation can play an important role in this. So let's speak a bit about that building performance simulation. First, about building performance. What is that actually, a performance-based approach? It means that we work with the end result in mind, not exactly with how we do it. How it is to be done, that is going to be the result. So the performance is about what the building has to do, not how it is built. And in order to, in that context, it's very necessary that we can assess the performance in an objective manner, both during design, construction, use, and maybe even later. The alternative would be a prescriptive approach, that you say, okay, you need to have so much insulation, or you need to have this type of glazing. That's not what is done anymore. So a high performance building, what we mean by that is a building that integrates and optimizes all major high performance building attributes: performance, occupant productivity, energy efficient, durability, in the whole life cycle. So now a few words about simulation. What is simulation actually? It comes from simulare, which means to pretend. You use a model and you pretend that the model reflects reality. In our case, it's a mathematical model of the system. And sometimes people think there's like one type of model which represents a building. That is not true. They can be of many different types. They can be for the whole building, maybe even for a district, or they can be for part of a building. And these models also depend on what you want to do with it. So you can have of the same building many different types of models. These models always have a limited validity range, also something very important to remember. So in our case, simulation, we mean the imitation of operation of a real-world building or district over time. For that, you first need to develop a model. And the model doesn't represent everything, like we just said, but it represents the key characteristics or behaviors of that building or the process. So the model represents the system, the building, whereas simulation represents the operation of the system over time. So how is, for example, building simulation used in the context of, let's call it, green design? How is green design guided? On this graph, you can see on the vertical axis something about performance. And so there are many buildings which have a minimum performance. They comply with the building regulations. There are very few buildings which have a very high performance. You can see these are like the leading examples. Yeah? And so in order to raise the lower bar, the tools which are needed there must be as simple as possible. Can be simple building regulations, but nowadays more and more you see there simulation being incorporated, or simulation is actually used to develop these simple tools. If you go to the higher performance, we can accept much more complex tools. And here it's mentioned LEAD and GB tool and CASPI, but also there we find that many more simulation tools are actually used. You can also think in terms of users. Yes, some users, and I'm speaking about designers or consulting engineers, they work towards very innovative buildings. Others are more middle of the road, and others are more like standard buildings. And so these innovators, they will use anything, including research type of tools. Then the early adopters, they are very eager to use tools, but they must be flexible, very expandable. The next category want easy to use and very robust tools. The next will do it only if it's mandatory and there are easy to use robust tools. And there's always a category who doesn't want to use simulation at all. So you can see amongst all people who use simulation or who want to use it, they have different requirements. So we need to have different tools for that. Simulation is used not only during design, actually still at the moment it's mostly used at the end of the design phase. But it should actually also be used already in the conceptual design phase. It can be used for documentation, during construction, and very important also during operation and maintenance. And that's actually one of the things which should make that more easy in the future is the connection to building information modeling systems. But there are other uses and applications. I mean, other than design. For example, you can use it for product development. It doesn't even have to be existing products. This can be like an imaginary product. Yes? Simulation is a very powerful tool to predict what will happen if a product has a certain characteristic, for example. I already mentioned that you can use it for standards and regulations. We can also use it for policy making. For example, in the context of climate change adoption, which are the buildings which are most at risk? Yes? And we can use it for various other types of building related research. Whenever we use modeling and simulation, quality assurance is really very important. And it's actually very difficult to do as well. We all know the term rubbish in is rubbish out. We also need to think about, it's not only about answering the question right, but we should answer the right questions, which is not exactly the same. In my view, there are few essential engineering qualities you need for modeling and simulation. First of all, you need to have knowledge and understanding of fundamentals and basic principles. For example, further on in the book there are chapters about lighting simulation, acoustic simulation, and these chapters will not tell you the fundamentals of lighting or acoustics or something like this. You have to have that from somewhere else. You also need to be able to creatively solve real-world problems. And one very important aspect in that is that you need to know which tools to use, when and how. And we hope that this book will actually help you in getting an appreciation for this. So simulation is really, it's a discipline. It's not just the software. Quality assurance can be achieved through appropriate level of resolution and complexity, to calibrate your software, make sure that you have validated software, and use an appropriate application methodology. There are actually many people interested in this area and working together. I mean, not only researchers but practitioners, etc. And we are mostly organized in the International Building Performance Simulation Association, or else you can say IBPSA. Some people actually say IPSA. I like IBPSA. And so in IBPSA, what does it do? It organizes conferences, international conferences, every 2 years. Next time we'll be in San Francisco in August 2017. We also have IBPSA newsletter, which comes out a few times per year, and we have a scientific journal, the IBPSA Journal of Building Performance Simulation. IBPSA is organized in many different chapters all over the world, and one of the examples is IBPSA USA. They offer many different resources. For example, the Building Energy Software Tools Directory is hosted by IBPSA USA, but they have tools from all over the world. The same is with unmet hours, sort of like a database or a platform where you can find frequently asked questions. They have a building energy modeling library, a building energy modeling book and wiki. And there are also other organizations more and more interested in simulation. For example, the architects organization, in this case the American Institute of Architects. They provide books and guidance on how to use simulation in their field of operation. And another example is the American Society of Heating, Refrigeration and Air Conditioning Engineers, who do a lot in terms of modeling and simulation for building related applications. And they even have a professional certification program. You can see here the link. Of course, there are other people who use or with who we work together. I already mentioned architects, engineers, but it can also be with structural engineers, builders and fabricators and owners. And the hope is that, again, building information modeling will make this cooperation much easier and much more productive or efficient in the future. Some people sometimes ask about, what is the cost of simulation and does it pay back? And here you see a small or a table developed by an architecture firm. They were looking at, okay, what is actually the, let's say, the cost of the modeling as an extra service in that architectural firm, and the annual modeled energy cost. And then you can see that actually that it's the payback is really very, very soon. So also in economic terms, it's a very wise thing to do. Now I give back the screen to Roberto Lamberts, who will tell you more about the book.
Hi, thank you, Jan. Speaking a bit about the book, in 2011, we are planning with the chapter authors a second edition for probably next year. So what you hear now was the introduction to building performance simulation. That is the first chapter written by Jan Hensen and myself. The next webinar that you are going to listen will be by Gottfried Augenbroe. He's going to speak about the role of simulation in performance-based buildings. Then we go to the third chapter of the book, Weather Data for Building Performance Simulation by Chip Barnaby and Drew Crowley. The fourth chapter is by ASHRAE Madhavi on people in building performance simulation. Then we go to the fifth chapter by Jeff Spittler on thermal loads and energy performance predictions. The sixth chapter 6 is on ventilation performance prediction by Jelena Srebrik. Chapter 7 by Christopher Van Treck on indoor thermal quality performance prediction. Chapter 8 on room acoustics performance prediction by ASHRAE Madhavi. Chapter 9 by Christopher Reinhardt on daylight performance predictions. Chapter 10 on moisture phenomena in whole building performance prediction by Jan Carmelet, Bert Blokken, Chij de Vries, and Dominique de Rom. Chapter 11 on HVAC system performance prediction by Jonathan Wright. Chapter 12, microgeneration system performance prediction by Ian Beausoleil Morrison. Chapter 13 by David Claridge on building simulation for practical operation optimization. Chapter 14 on building simulation in building automation system by Greg Hansen, Christian Neumann. Chapter 15, integrated resource flow modeling in the urban built environment by Darren Robinson. Chapter 16, building simulation for policy support by Drew Crowley. And chapter 17, it's a view on future building system modeling and simulation by Michael Wetter. So the book chapters have a common structure. So the first, to give you an example, we have here the introduction. So we normally start with the scope, learning objectives, keywords, then we go introduction, discussion, a synopsis, and then we end up with recommended reading. So further reading that will be recommended to you on the subject of each chapter. And some activities. So the activity of the first chapter is, after reading parts of this book, please email your feedback to Jan Hensen and myself. So to conclude this webinar, building performance simulation has a very important role in more sustainable and resilient buildings and cities. IBPSA has a very important role in gathering the scientific and practitioner community to achieve these objectives. The book Building Performance Simulation for Design and Operation can help you to learn and understand better this interdisciplinary work. This webinar organized by CEPT in India for IBPSA will put you in touch with the chapter authors and give you a glimpse of the contents of the book. We hope you enjoy them. So thank you very much for listening, and we hope you enjoy the book.
Thank you, Roberto, and thank you, Jan, for providing this introductory webinar. This is the first in the series, and many more to come. I request participants to keep checking the IBPSA website for this, and now we take questions. Thank you.